Principal angles. The smallest of the positive coterminal angles is called the principal angle. So there's one little thing at the bottom right here. The principal angle will always have a measure between 0 and 360 degrees, or 0 and 2 pi radians. So determine the principal angle for the following angles. Well, 265 is between 0 and 360. So my principal angle is just going to be theta equals 265 degrees. Now for the 1085, we notice the 1085 is well above 360. So what I do is I just keep on subtracting 360 from this. I go 1085 minus 360, which equals 725. I notice that's still above 360. So I subtract it again, 725 minus 360, and that gives me 365. And then I go 365 minus 360, which would give me 5 degrees. So that tells me that my angle is going to be theta equals 5 degrees. Now right here, we have that negative 752, and we notice that's a negative number. So instead of subtracting 360, what I'm going to have to do is I'm going to have to continually add the 360. So I go negative 752 plus 360, and that gives me negative 392. I go negative 392, and I add 360, which would give me negative 32, and I go negative 32 and I add 360, which will give me 328. So here, again, my principal angle is going to be theta equals 328 degrees. Now here what we're working with radians, so I'm going to have to be using my 2 pi as opposed to using the 360 degrees. So I go negative 3 pi by 4, and we know that 2 pi is going to be equal to 8 pi by 4. So in total, this will give me 5 pi by 4. So in this case, my principal angle is theta equals 5 pi by 4. 13 pi by 6, 13 pi by 6. I minus the 2 pi, which will be 12 pi by 6, which will give me pi by 6. So in this case, I get my theta equals pi by 6. Finally, my negative 22 pi by 3. What I'm going to do is I'm going to add the 6 pi by 3, and this will give me negative 16 pi by 3. I go negative 16 pi by 3, and I again add the 6 pi by 3, which will give me negative 10 pi by 3. And we repeat this process again. Obviously, you guys can probably expedite this a bit beyond how fast I'm doing it, but I'm just kind of justifying every step. So I go negative 4 pi by 3 plus 6 pi by 3, and that gives me 2 pi by 3, which is finally getting to my positive one between 0 and 2 pi. So here I get that theta is equal to 2 pi by 3. Now the quadrantal angles, those are angles whose terminal arm falls on the x and y axis. So this is just if I set the axes up like we had before, 0, 90, 180, 270, and 360, or subsequently 0, pi by 2, pi, 3 pi by 2, and 2 pi. We're going to quickly move on here, just because this video hasn't been too long. Reference angles. For angle theta in standard position, the reference angle is the positive acute angle that is formed by the terminal arm and the x-axis. As well, it will always be between 0 and 90 degrees. So for my reference angle, what basically happens is we can have our terminal arm in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. No matter what quadrant it's in, we read the reference angle from the x-axis. So here it just reads like that, there it reads like that, down here it reads like that, and from here it reads like that. It's always going to be acute, meaning it's always going to be under 90 degrees and above 0 degrees. Well, let's kind of check out how this is going to work, looking at these angles right here. So 120 degrees. Well, 120 degrees goes beyond 90 and it reads up to right there. So we get the theta equals 120 degrees. We know that this is 180 degrees. So I read the angle from my x-axis back to where the terminal arm is, and that would give me 60 degrees. So that means that my theta, or if I want to go theta reference, would be equal to 60 degrees. 370 degrees, 375 degrees, sorry, gives me one wraparound, and then it comes up right there to the 15 degrees. So we minus that 360 from it, we're left with the 15, and here I'm going to get my reference angle is equal to 15 degrees. Negative 780 degrees. So negative 780 degrees, well, that gives me one backward circle, two backward circles. And if we just quickly go negative 780 plus 360 plus 360, that leaves us with negative 60 degrees. So that means that negative 60 degrees will look like that. But we're just reading the angle from the x-axis to the terminal arm. So that means that my reference angle is going to be equal to 60 degrees. Not the negative 60 degrees, it's going to be equal to 60 degrees. Okay. 8 pi by 3. 8 pi by 3 gets a bit trickier, but we notice that we can subtract that one full rotation, or the 2 pi, from it. So I go 8 pi by 3, and then I subtract the 6 pi by 3, and that leaves me with 2 pi by 3. So now looking at this one, whoops, kind of went off of that. So now, looking at this one, if this is 0, this is pi by 2, and this is pi, well, we know 2 pi by 3, 2 divided by 3 is about 0.66, so it's going to fall in my second quadrant right there. So if we want to know what this angle is right here, I just go pi minus 2 pi by 3, which would give me 3 pi by 3 minus 2 pi by 3, and this would just equal pi by 3. So the angle coming up right there is pi by 3, so my theta reference would be pi by 3. 15 pi by 4, again I enact the same process. I go 15 pi by 4, and I subtract the 8 pi by 4, which would be the 2 pi, and that would give me 7 pi by 4. So then, zero, pi by 2, pi, 3 pi by 2, and 2 pi. We know that 7 pi by 4, 7 divided by 4, is equal to about, give or take, oh my god, I forgot for that second. 7 divided by 4 is equal to about 1.75. So right here, 0 pi, oh, that's 3 pi by 2, not 3 pi by 4, my bad. we know that it's going to read somewhere up right there with that 7 pi by 4. So now, to find out what that little piece right there is, I'm just going to go 2 pi minus 7 pi by 4, or 8 pi by 4 minus the 7 pi by 4. And that leaves me with pi by 4. So that means my reference angle, or my theta r, is just going to be equal to pi by 4. Lastly, negative 13 pi by 6. We need to get this to its positive angle first, so I add the 2 pi, or I add the 12 pi by 6, which gives me negative pi by 6. Then I go negative pi by 6 plus 12 pi by 6, and this will give me 11 pi by 6. And right here what we get is we read the angle. 11 pi by 6 is a bit more than 3 pi by 2. And it comes out right there. So that's 11 pi by 6. But again, we want the angle that's from there to there. So I go 2 pi minus 11 pi by 6, or I go 12 pi by 6 minus 11 pi by 6, and that leaves me with pi by 6. So that angle is pi by 6, which means that my reference angle is going to be pi by 6. The next thing we're going to get into is the unit circle. I hope you all have enjoyed.